Hi guys, this is my video about black holes. I hope you guys learn a lot and enjoy.
Black holes are a phenomenon predicted by Albert Einstein's general theory of relativity, which was published in 1916. In fact, the idea of a black hole was proposed as early as 1783 by the amateur British astronomer John Michell, and independently by the Frenchman Pierre-Simon Laplace in 1795. Ironically, Einstein himself did not believe in the existence of black holes, and he strongly resisted the idea even though his own theory predicted them. The general scientific consensus is now that black holes do in fact exist, and that they are actually one of the most important features of our universe. Astronomers have detected them indirectly in enough ways that there is little doubt of their existence. To explain what a black hole is, first you have to know what a star is. A star is a cluster of mass where at the core is an immense amount of nuclear energy. In the core is constant atomic fusion of atoms. For those that don't remember from chemistry, it's where elements form to combine new elements. The act of atomic fusion releases an immense amount of nuclear energy, creating a force outwards from the core. Now, if there's atomic explosions occurring within a star, how does it stay, well, a star? This is because of gravity. The mass of a star is so huge that the gravitational pull is able to keep together particles within the core of the star, despite the nuclear explosions. When the outward force of the fusion and the gravitational force of the star are equal, this is known as hydrostatic equilibrium. Now, even though stars do this fusion thing for millions of years, at some point there is not enough energy and the elements at the core of the star are too heavy to fuse anymore. This is what is called a dead star. Now, before we continue, there is something we must learn. It's this symbol. This symbol represents the mass of our sun, which is approximately 1.989 times 10 to the 30th kilograms, and it's called the solar. This is the unit used to describe mass in space. The Chandrasekhar limit is a limit at the mass of 1.44 solars. If a dead star has less than this much mass, then it is called a white dwarf, and the outward force is instead created by electrons rather than fusion and is called electron degeneracy pressure. I have no idea what that means, but it's some kind of outward force. The range between 1.5 and 3.0 solars is considered the Tolman-Oppenheimer-Volkoff limit, and this is considered a neutron star because instead of the outward force being held up by nuclear energy or electrons, it is held up by neutrons, or also known as the neutron degeneracy pressure. Now, when the mass of a dead star exceeds the mass of 3 suns, it becomes a black hole. This is where the pressure from inside the core is too weak for the gravity of all the mass. The atoms all collapse on themselves and is pressed into an infinitely small point, or a singularity. Since we learned about gravity in class, let's calculate the gravitational force of the smallest possible black hole. The force of gravity is equal to the universal gravitation constant, which is 6.673 times 10 to the negative 11th newtons times meters squared all over kilograms squared, times the mass of one object times the mass of another object, and all of this is divided by the distance between the two objects squared. The mass of one object in this case is the smallest possible black hole, which is approximately 5.96 times 10 to the 30th kilograms. Let's make the other object, let's say, an average human at 80.7 kilograms. We're going to make the distance the same distance as we are from the center of the Earth to keep things consistent and relatable, which is 6.38 times 10 to the 6th meters. If you do all the math, you end up with the force of gravity being 7894 something 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 newtons. This is almost 1 million times stronger than what we're currently experiencing as of right now. The biggest black hole currently known to man is called the Holmberg 15A and is approximately 170 billion solars, which in turn would make the gravity we would feel about 1.69 times 10 to the 17th times stronger. Without a doubt, we'd all be dead.
I'm done. Thank you for watching. Yeah.